Hello everyone, my name is Ritesh Moite and today I am presenting a PPT presentation on discrete mathematics ISC activities weekend. So let's begin our presentation. Today we are going to see lattices as pure sets, that is partial order sets and their properties. First we will see the lattices as pure sets, its definition with some examples and then their properties in detail. Let us see the definition of lattice as pure set. A lattice is a partially ordered set L, G in which every pair of elements such as A, B belongs to L has greatest lower bound and least upper bound. That is, if every pair of elements in that pure set has greatest lower bound and least upper bound, then that figure can be considered as a lattice. What is least upper bound? The LUB or supremum of a pure set A, B belongs to L is denoted by A join B or A plus B. It is also called as join or sum of A and B. And thereafter GLB, that is greatest lower bound, also called as infimum of pure set A, B belongs to L is denoted by A meet B or A star B, and it is also called as meet or product of A and B. Let us consider for an example. In this figure there are 4 vertices 1, 2, 3 and 6, and first table shows the least upper bound of the figure. For pair 1 and 1 it is 1, for pair 1 and 2 it is 2, for pair 1 and 3 it is 3, and for pair 1 and 6 it is 6. Likewise for pair 2 and 1 the least upper bound is 2, and for 2 and 2 it is 2, for 2 and 6 it is 6, and for 2 and 3 it is 6. Similarly for each and every pair there exists a least upper bound, and here for greatest lower bound for figure 1 and 1 it is 1, for pair 1 and 2 it is 1, for pair 1 and 3 it is 1, and for pair 1 and 6 it is also 1, for pair 2 and 1 there is greatest lower bound, that is 1, for pair 2 and 2 there is 2, for pair 2 and 3 the greatest lower bound is 1, and for pair 2 and 6 the greatest lower bound is 2. Similarly for every pair in this figure there exists greatest lower bound. Hence in this figure for every element in the given set both least upper bound and greatest lower bound exist. Hence this pure set is called lattice. In this figure, if we consider a pair 3 and 4, it has same relation with 1 and 2. The greatest lower bound of this pair is not clear. Hence, this figure cannot be considered a lattice. Let us see the properties of lattices. Consider a lattice L, less than equal to, and the two binary operations meet and join, denoted by star and plus, used respectively. Then for any three elements A, B, C belonging to L, the properties of lattices are: first one is idempotent, in which A into B is equal to A and A plus B is equal to A. Second property is commutative property, in which A into B is equal to B into A and A plus B is equal to B plus A. Third property is associative property, in which A into B into C is equal to A into B into C. Similarly, A plus B plus C is equal to A plus B plus C. Hence, we have seen the properties of lattices. Thus, in this presentation, we have seen lattices as pure set and their properties. So, we end our presentation here. Thank you.